Hello and greetings to everyone. Today we are going to see how to differentiate y equal to the log of f of x base a, where a is a positive real number and f of x is a function of x. That means we are going to see how to differentiate logarithmic functions. First, if we take y equal to the log of f of x base a, then it simply implies that e to the power y will be equal to f of x. Going back to the index form. Now, if we are to differentiate both sides, this will imply that e to the power y, the derivative of e to the power y, will give us, let's find the derivative of e to the power y before we state it by the side so that people don't get confused. If we say let e to the power y to be equal to a new function u as such, then if we take ln on both sides so that we bring down the power y, the ln of u will equal to the ln of e to the power y, and this will imply that ln u will be equal to y ln e. Differentiating ln u with respect to y, this will give us 1 over u du on dy to be equal to differentiating y ln a with respect to y gives us ln e. Next step, we have to multiply through by u, then du on dy will be equal to u ln a. U ln a will simply be equal to, we have to replace u with e to the power y, so this will give us e to the power y ln e as a derivative of du on dy. That means the derivative of e to the power y is simply e to the power y ln e. Take note of that. From here we continue. This will simply imply that differentiating both sides with respect to x, this will give us the derivative of e to the power y is simply e to the power y ln e times, since we are differentiating with respect to x, times dy over dx is equal to, we differentiate f of x with respect to x, this will give us the f of x on dx. We are looking for dy on dx. What we are going to do is we are going to divide both sides by e to the power y ln e. This will imply that dy on dx will be equal to 1 all over e to the power y ln e times the f of x on dx as such. Next, what we are going to do is we are going to replace e to the power y with the function f of x, because we want the right hand side to be in terms of x. This will imply that dy all over dx will be equal to 1 all over e to the power y, which is f of x, times ln e times the f of x on dx. The derivative of y equal to log f of x base a is dy on dx equal to 1 all over f of x ln a times the f of x dx. Now let's take an example. We see how to apply this formula and to get the derivative. We take this example, e.g. y equal to the log of -4x squared plus 7x base 2. We have to find dy on dx, dy on dx is equal to, that's what we are looking for. First step, we need to start by identifying the function f of x. F of x is simply equal to what we have in brackets here, which is -4x squared plus 7x. Then we need the f of x on dx. This will give us differentiating this will give us -8x plus 7. Next, we need to identify e. E is the base, which is 2. E is equal to 2. Then the ln of e will simply be equal to the ln of 2. Now we can proceed to write down the derivative of log -4x squared plus 7x base 2. This will give us dy on the x to be equal to, making use of this formula, 1 all over, we take f of x, which is -4x squared plus 7x times the ln of e. The ln of e is ln 2 times the f of x on dx, which is -8x plus 7 over 1. This will simply be equal to, multiplying this to, this will give us -8x plus 7 all over -4x squared plus 7x times ln 2. Because if we take this times 1, it remains this. So this will be the derivative of y equal to the log of -4x squared plus 7x base 2. This is how we differentiate logarithmic functions to a given base. If in case you have any worries on this, feel free to drop your questions at the comment section. Please, if you like the video, share and subscribe to this channel. Thank you very much for watching.